Chapter 3.2, we're looking at quadratic functions in standard form. So again, that standard form is that ax squared plus bx plus c. So this one is asking you to graph each of the functions using your graphing calculator, determine the coordinates of the vertex, the intercepts, round to the nearest tenth where necessary. So a couple things here. All this is telling me is what my window should be. This is the equation that I'm putting in my y equals. So quick review of the graphing calculator. So if I want to graph something, I'm going into that y equals. Let me do it like that. I'm going into y equals, and I can type in whatever I want. Oops, that's a squared. So I can put x squared and plus 5. And if I graph this, it should look something like this. Now, if you have a graphing calculator that someone else has used, maybe your window is messed up a little bit, remember that we looked at, you can do sum 6. That will bring you back to that basic -10, +10, -10, +10 window. So I'm 10 each way. You can also, if you would prefer, go in and change your window settings. So if I wanted to see higher up, so I could see more of the top of this quadratic, I would go down to my max y. So I want to change my y, and I want to see a bit higher, so maybe I'll change that even to a 20. Now if I graph that, I can see a little bit more of my quadratic. So know how to work your window settings so that you can see what you need to. Now, if I want to find my vertex, what I can do here, and this one's pretty easy, you know it's going to be at 0, 5, but if I wasn't sure, just for a little review, we can do second function, trace, and I want to find, in this case, a minimum. So your vertex is either your minimum or your maximum, so I'm going to select minimum. And then it's going to ask me, are you left bound, are you right bound? So you just want to move your cursor so it is to the left of the vertex and hit enter. And then you want to move your cursor so that it is to the right of the vertex and hit enter. And then you can hit enter again on guess. And this will give you the vertex. So I'm glad this did this because we run into a little bit of an issue here sometimes. Sometimes the calculator gives you something that looks like this. This would be 0.00000018, which essentially would be 0. So you could put that down as 0. Y-intercept. Again, you can grab that from your equation, but we could calculate this under second trace value. And I know when I have a y-intercept that my x value is going to be 0, so I type in 0 and hit enter, and that would give me my y-intercept. I can see from this that there are no x-intercepts, and we'll look at on the second example on how to calculate that. So you can find a bunch of information from your graph. So let's do the next one, which I'm going to have negative x squared and then minus 2x and then plus 5. So remember, if you have a negative in the first thing, use that little, you can't see it, it's kind of right down here under the 3. Use that button instead. So I can use a window of 10 by 10 if I wish, and if I want to go back to that, sum 6 and enter. Oops, I froze it. That's okay, you get the idea. So once that graphs out, it's still thinking right now. Once that would graph, you would end up with something like this. So this is what I'm putting into my y equals. This would be the window I could use. That would give me the best view of that quadratic. There, so we got it to work. So my vertex, again, this time I'd have to choose maximum, left bound, right bound. But I want to show you the x-intercepts. So remember last year we did second, we did trace, and we want to choose 0. So 0 is another word that we use for x-intercept. Depending on which one I'm looking for, it's going to ask me, are you to the left? So I'm going to find this one right here first. So yes, I am to the left, I'm above. And then are you to the right? I'm going to move down to the right. Remember, you're going to change your sign. If you're above the x-axis for one side, you're going to be below for the other. Guess we can guess. And that will give me my intercept of 1.44, so I round it to 1.4 and 0. And then if I want to do the other one, I can do the same thing. Second, trace, I'm looking for a 0. Again, they're asking left bound. So this time left bound is actually going to be below my x-axis. So there's my left bound, and right bound I am above. So I'm just hitting enter down here. I know you can't see that. And then I have my 0. So negative 3.4 in this case. So for example 2, and I already have this graphed, it's giving you a rock is thrown off a cliff, The height in meters with respect to time is defined by this quadratic. So what I've done, I've gone in and I've put this quadratic in my y equals, and then I graphed it. But I did need to change my window. So I knew that just from the numbers that I have here, I know my y-intercept is going to be already at 50. I know my vertex is going to be 463, so I actually had to change my max y value to 500. My vertex, my middle is going to be about 10, so I actually went and changed that to 25. Your settings don't have to be exactly the same, but you do need to be able to see your quadratic. And then from there, I can find all my values. So sometimes with a word problem, the trick is, okay, maximum height, what does that correspond with? So maximum height would correspond with my vertex. So I would go in, remember second function trace. This case, I'm choosing a maximum. I might have hit minimum there, I can't remember. And choosing a maximum, I should have, so left bound to the left of my vertex, and then right bound to the right, and enter will give me the value of my vertex, which I already have here. And then from there, we can grab a lot of information. So maximum height would be my y value of my vertex. This is in meters. Make sure you actually put your units there. When does it reach this height? 9.18 seconds. How long until it reaches the ground? So a couple things you could do here. You could go back to your graphing calculator and solve for your 0 if you want to. Or you could figure out, oh, not really from this one because it's not starting from 0. Scrap that. We'd actually have to go in and do a second trace. If it started from 0 and you knew what your axis of symmetry was, you could just double it. But in this case, I really can't do that because it's not starting from 0. It's actually starting already from a height. So am I to the left? I am. Quite to the left. So I'll hit enter. And then am I to the right? And if you can't quite see, you can always look and wait until I'm way below. Now I'm at a negative 167, so we're good. So enter, and that gives me my 18.9, and I'm going to round that to 1. So it's almost double. Not quite. So it's in the air for almost 19 seconds. How high is the cliff? So it's thrown off the cliff. So this 50, this y-intercept would be where it's thrown from. And then the domain. So remember I said a bunch of times that domain is always x, x is in the set of real numbers. In this case, because it is a problem-solving situation, it is only in the air between 0 seconds, we can't have negative time, and then it hits the ground at 18.91 seconds. So you would have to include that with your domain and range. So that's the only case where you'd actually have those restrictions. All right, so now some fun problem solving. So it says two numbers have a difference of 10, and their product is a minimum. Determine the two numbers. So what I can do here is I can let x equal a number. So one of my numbers will be x. The other number would be x plus 10, because they would have a difference of 10. If I did x plus 10 minus x, I have 10 left over. So the difference is 10. And I know that their product is going to be a minimum. So product is multiplication. So if I multiply my x and my x plus 10, that would give me x squared plus 10x. So if I go in and I graph this on my graphing calculator, I will have a graph that looks something like this. So I have this graphed. I can go in here and calculate this minimum. And if I do that, if I do second trace minimum, I will have a minimum of negative 5 and negative 25. So in this case, my x is going to be equal to negative 5. So one of my values will be negative 5. My other value will be negative 5 plus 10, which would give me 5. So let's see. Difference is 10. Yep. And product is a minimum. So negative 25 is part of my minimum. And then one more. And I have this one filled in already just for sake of time. So rectangular pen is to be built. They want to find the maximum area, the 60 meters of the fence, with one side as the enclosure. So what you have here, you have the barn, then you have the height and the length, or the width and the length. So I know that 2x plus y will give me 60. If I add this plus this plus this, I have a 60 meter enclosure. And I can rearrange that equation for y. So y is equal to 60 and then minus negative 2. So then what I can do, and this is the reason I wanted to do this, I wanted to have my function as a function of y, because I know the area would be x times whatever y is equal to. That would give me my area. So y is equal to 60 minus 2x. So So x times 60 minus 2x, and all of a sudden, I have a quadratic. Your hint for this chapter is if you get a word problem, you're probably going to have to make a quadratic out of it somewhere. So, same idea. I went and I plugged this into my graphing calculator, and I found my vertex. And remember, we're looking for a maximum. And in this case, because I have that negative 2x squared, it will give me my maximum. I calculated my vertex, and then from my vertex, I could grab my values. So I know that if I have an x value of 15, and I plug that in, that will give me my right enclosure area. So my x is going to be equal to 15. My y in this case, if I wanted to figure out what that was, I could say, okay, 2 times 15, that's 30. So 60 minus 30 would be 30. And then I have my dimensions that would give me the maximum area.